Howdy everybody, Cliff here from 8 Ions with phase 2 of DevOpsing with Python. In this video we'll be looking at remote invocation with Fabric, Salt, and Ansible. We'll be using Salt and Ansible modules to see what information is available about our systems, and we'll look at what happens when we install a package. You'll notice here I am logged in to the same VM that we had set up in the environment setup and phase 1. This is actually in the same condition it was when we left phase 1. If I do a word and list, you can see all of my jails there. I'm actually going to go ahead and destroy these jails and then rebuild them from scratch, because that'll give me a chance to show you how you can do some things with Fabric. So I'm currently logged into my tmux session. If you're not aware of what tmux is, please go back and check out the phase 1 video. I'm in the root for my user. In my user's home directory. I'll go ahead and switch to prog. Workshop 00 and phase 1. And from here, I can invoke Fabric, and we will use our delete jails. Actually, if I don't remember what it is, I can just list all of the tasks. And of course I'm in the wrong directory. Alright, so now I could just list all the tasks. By the way, from that previous directory, if I wanted to, where this list failed, I could simply specify what Fabric file to use using -f. And there we'd have it. So I'll go ahead and run delete jails. And that should go ahead and remove all of the jails that we've already built. Okay, it looks like that's done. And running a word and list shows us that we have no jails here. If you have one, you'll probably want to remove your known hosts file. Okay, let's go ahead and rebuild our jails. One thing that I didn't mention last time is that you can run multiple tasks simply by listing them one after the other, separated by a space. They will run in the order listed. Due to a software bug, we'll need to run provision sudo after the other steps have finished. Okay, and it looks like we're done. Now, that whole process wasn't anything that we had to do. I simply wanted to show you that if we did a build, of the environment using the scripts that we had from before, we would actually have the same result as last time, and these are actually hosts that you can SSH into as if they were out on a network somewhere as different physical devices. So I log in as the user student00 with the password of student00.password, and it drops me into a box. If I type hostname, it'll tell me that I'm on jail 07. I can use the package tool to get information about the packages that are installed. One thing that's different about running in jails is that reboot doesn't do anything as far as restarting the system. So if you issue the reboot command, it'll simply tell you that that signal has no process. Other than that, it's basically like any other remote system, and they're all distinguished from each other. If I look at the process table for my particular jail, it has very few things running in it. and I can't see from inside this jail any processes running either on the host system or on other jails. So we'll go ahead and exit. Now that was all from phase 1. Let's back up and go into phase 2. If we look at the tree for phase 2, we can see that we have an Ansible directory, a Fabric directory, and a Salt directory. And then under Salt, we even have a config directory. Since we have hosts to connect to, it's probably a good idea to create an SSH key. I've already got one created, but if you want to make your own, you can just use the SSH keygen command. I've created a Fabric task that will push my SSH key out to various hosts. In addition, I've created a task to patch Salt because there's a bug that's fixed in later versions of Salt that isn't in the version that we're running. So we'll want to get this applied as well. First, let's push out our SSH keys. Here I'm using -h to specify the host name of jail00 on the command line. And the task that we're going to run is ssh_push. And here I'm prompted to enter my password. Let's test it by seeing if I can SSH without being prompted for a password now. Looks like I got in. If I'm going to do this for the next host, I can simply go back, change this to a 1, get prompted for my password, enter my password, and it looks like that one worked as well. Okay, now I don't want to have to type my password in every time that I connect to a host. So I'm going to use the -- password option. And see if that can make things a little bit better for me. Wow, that was much better. I can also specify multiple hosts. And I can even run everything in parallel, so that it's not going out to one host doing work, waiting for that work to finish, and then going to the next host. With the -p option, I can have it handle multiple hosts at once. That's a lot better. And I also don't have to SSH out to each of these hosts individually to test them. Now that my SSH key is out there, I don't have to worry about supplying a password. And let's say I want to run this without using the without passing a task. If I simply do a double hyphen or dash mark, I can type in any command I want, and it'll get executed on the remote hosts. Now, it may be difficult to see, but here's the host's name that was running the command, and here's the actual result of the command that was run. Maybe I'll do something that might stand out a little bit more. And here we have the results. So that was great. Let's go ahead and do our patch for salt before we forget. Now this happens to be a local patch or a local task, so we don't need any of these hosts. All right. Now let's take a look at Ansible. Ansible makes use of inventory files or host files to get the information it needs to be able to connect to hosts. Here we have a number of hosts that are in the base of our host file. This covers all of our jails from 00 to 09. We also have classes of hosts specified further down in the file. I'll leave it as an exercise to the user to find out what those are for and how they get used. It will come up again later. Here we have here we are setting the Python interpreter because Ansible expects it to live in some place like user bin Python, and on many Unix systems it's not there. We're using FreeBSD, and when we install Python it goes to user local bin. Ansible can also run arbitrary commands on the command line of each host that we connect to. You might be prompted to accept the server key or the host key the first time that you connect. There is a way to override this, but for now, we'll just go ahead and click and type in yes. We have all the host keys accepted. We can go ahead and rerun the command, and we won't get prompted again. In addition to running commands, we can execute standard modules. Including the module that gives us information about the system. This is the setup module, which collects a number of facts about each host that it connects to. I won't go into too much detail about what's here. I recommend that you take a look at it when you get a chance and find out everything that's in here. It turns out to be pretty useful when you're building playbooks. Now, how about we do something awesome like install Salt using Ansible? I don't have to target every host. I've been using the all keyword. Instead, while I search for this package, I can limit my execution to one host. Rather than calling the command module and executing the package command, I'll call the package module. Here it says that the process failed. That's because I need to use sudo since I'm not a root user and I'm trying to install a package. It looks like that installed successfully. Let's go ahead and try it on another host. Okay, it looks like we're 2 for 2. So let's go ahead and do this on all the hosts. Notice that when I switch back to the keyword all, it's going to run the process on all of the hosts defined, including those that we've already done individually. By switching back to the all keyword for hosts, we ensure that it executes the module for all of the hosts defined in the inventory file. Because it's running on multiple hosts, I'd like for it to get done as quickly as possible. So I'll pass the F option for it to run parallel processes. We'll let it run 5. Okay. Notice that here we have success for the hosts that had the package installed. And we had a couple of places where the package was already installed. And notice that for those hosts, even though the change came up as false, the execution was still considered a success. What that means is nothing had to be installed to get to the desired state. That's considered a success. Whereas before, when we had tried the install without the proper permissions and we couldn't install anything, that was a failure. All right, that's a quick rundown of Ansible. Let's take a look at Salt. Now for Salt, we do have a few more things that need to be set up. Let's take a look at this Salt file. Salt has a configuration directory, and for our purposes, we're going to be overriding that, setting it to .config in our phase 2 Salt path. We're going to set max procs to 30. That tells us how many forks we can run, or how many individual worker sessions we can have. Wipe SSH we don't need to worry about. User we are setting to student 00, and root dir actually doesn't need to be set in this file. Let's take a look at config. So under config, we have a master file. There are a number of things that are in this file that don't need to be worried about. There are some things, however, that need to be overridden if you're going to be running as a non-root user. By default, Salt looks in certain places to drop PKI files or caching files or other things. So I've just supplied this file with all of the paths pointing to things under the home directory of our user, and that should let us run everything without a problem, especially now that we've got our Salt installation patched. Much like Ansible and Fabric, Salt can also execute arbitrary commands over SSH on hosts that we connect to. Here I'm specifying the private key file for our SSH key pair to use for authentication against the hosts. The star here, or asterisk, indicates that we want to connect to all hosts that are specified in our roster file. I'll cover the roster file in a minute. -R simply means execute these on the raw shell, and in this case we're calling the ID command. Like Ansible, we can also call modules instead of just executing arbitrary shell commands. Ping simply tells us that a host is responding, but we also have a whole array of modules that we can run. Among them, we can list out our grains, which is similar in many respects to the Ansible setup module. We can do grains items. Let's limit this to a particular host. While the format is different, the grains items listing has much of the same information that's available from the Ansible setup module. I'd recommend that you take a look at them both and find out what's available in each one. Since we had Ansible install Salt, I think it's only fair that we have Salt install Ansible. And let's run this on all of them. Again, the output is a little bit different for Salt, but we have a listing of the packages that were installed for every host that we had specified. Speaking of specifications, let's take a look at that roster file. So here's a roster file. Basically, we list every host by a label, and then either the host name or the IP address and the user that we want to connect as. We could have the same IP address or host name in there multiple times with different users to connect as. And then because some of the operations that we were doing required root privileges, we had sudo set to true. That about covers it. It was a quick run through using the command line to connect to remote hosts using Fabric, Ansible, and Salt. With Salt, we installed Ansible. With Ansible, we installed Salt. Next time around, we'll take a look at doing some configuration management with Salt State and Ansible playbooks. In the meantime, I recommend that you take a look at the Salt modules and see how you can execute those from the command line using Salt SSH. Likewise, for Ansible, take a look at the modules. The link will be in the description. Please play around, do some discovery, and I'll see you next time.